Here's how to add, subtract, multiply, and divide functions explained in just one video. So here's the first example we'll be doing in this video. We have to find f plus g of x. So you've probably heard of f of x before and g of x. They mean the same thing. They're both just functions. So they're like an equation here. So whenever you see f plus g of x, that just means that you need to add the functions together. So what is f of x? Well, f of x is 3x minus 2. So we're going to put 3x minus 2, and we'll put it in parentheses. When we do later problems, you'll see why. And then we need to add g because it's f plus g. Well, g in this case is 5x plus 1. So we're going to add 5x plus 1. So when you're adding these together, the parentheses don't really matter because you can add in any order. So we can actually just ignore these parentheses and add together the parts with x and add together the numbers by themselves. First, let's look at the x's. We have 3x plus 5x. 3 plus 5 is 8, and the x stays. And then here we have not 2, minus 2. The minuses always stay. We have minus 2 plus 1. Well, think of this as dollars. You lost $2 and you got 1 back, but you're still down $1. So minus 1. And that's it. We have added together the functions. So we've just found f plus g of x. Now here's another example. This time we need to subtract functions, and this time we're doing g minus f. So we're going to set this up the same exact way as before, but with a minus sign. But instead of putting f first, we're going to put g first, because g is first in this, g minus f. So we have 5x plus 1 for g, and then minus, because we're subtracting, f, which is 3x minus 2. Now here's why we had to put these in parentheses earlier, because with subtracting, the order matters. And if you want to think of this like distributive property, the minus is being distributed to both parts in parentheses. So we can rewrite this without the parentheses, but we need to distribute the minus sign. So the 5x minus 1 is going to stay like normal, and then we're going to apply the minus sign. So minus 3x, that's minus 3x. And then we have minus minus 2. Because this already has a minus, adding another minus turns it back into a plus. So we're going to have plus 2. Now we can just add the parts with x and add the parts by themselves. So we have 5x, not 5x plus 3x. This minus sign here is here, right? So 5x minus 3x. 5 minus 3 is 2, and the x stays. And then we have minus 1 plus 2. That's the same thing as 2 minus 1. 2 minus 1 is 1. So that's plus 1. And there we go. G minus f of x is 2x plus 1. All right, now we need to multiply these functions. And it's going to get a little bit harder, but it's going to be kind of the same principles. So to multiply these, we need to take f, which is 3x minus 2, and it's being multiplied by 5x plus 1, which is g. And remember that to multiply two binomials is just the fancy way of saying something in parentheses with two parts, we need to use something called FOIL. So the first step of FOIL is f, which stands for first. So we need to multiply the first parts here. 3x times 5x. Well, 3 times 5 is 15. And then it's x times x, which is x squared. Now we need to do outer, which means we're multiplying the outer parts. So we have 3x times 1. Well, anything times 1 is itself, so that's just 3x. Then we have I, which stands for inner, so we need to multiply the inner parts. So we have negative 2 times 5x. Well, 2 times 5 is 10, and then the x stays. And then we have 1 minus sign, so the minus sign stays as well. And then finally we have L for last, so we need to multiply the last parts. So we have negative 2 times 1. Anything times 1 is itself, so that's just going to be negative 2, or minus 2. And now I'm noticing that we have two parts here that have an x. That means we can combine them, which is called combining like terms. We can't also combine the one with x squared because x squared is different from just x by itself. So we have plus 3x minus 10x. If you want to think of this as dollars, we had 3, and then we lost 10, so we're down 7. So minus 7x, and then minus 2 stays. So here we go. This is our final function for f times g of x. And now finally, we need to divide functions. So we need to find g over f of x. And remember that fractions are the same thing as division. So you could also say this as g divided by f. So we're going to write this the same exact way. We're going to write it like this, except instead of g, we're going to put 5x plus 1. And instead of f, we're going to put 3x minus 2. Now, there's actually nothing else we can do to simplify this, because if you were to divide something out, you'd have to factor something out of the top and the bottom. It would have to come out of all these parts, and you can't do that with this. Now, if you had some like x squared or x to the third thing in the top, then there's a chance you could actually divide them using long division. But in this case, we can't do that. But there's one more thing we need to do. With all the other ones, we could put in any number for x. It doesn't matter what we put in. But there's actually one number that we can't put in for x in this. Can you figure out what it is? We'll look at the bottom here. If we put in a certain number for x that made the bottom of the fraction 0, we would be dividing by 0. And we can't divide by 0. So let's go ahead and figure out what number we can't put in for x. Remember, we can't put it in for x if it makes the whole bottom 0. So if 3x minus 2 is equal to 0, then the bottom is 0. So let's go ahead and solve for x here and see what we get for x. So to get x by itself, we have a minus 2 here. We'll do the opposite of minus, which is plus. We'll add 2 to both sides. These cancel out, and we're just left with 3x equals 0 plus 2, which is 2. And now we're just left with multiplication. So we need to do the opposite of multiplication, which is division. So we'll divide both sides by 3. These cancel out, and we just have x equals 2 divided by 3, which is, well, 2 over 3. Nothing you can really do about that, right? So if we put in 2 over 3 for x, then we're going to get 0 on the bottom, and we're going to have an impossible equation. So even though this right here is our final answer, because there's nothing we can do, we also have to add that we can't have x equal 2 over 3. So we're going to put this little not equal to sign. But yeah, there's nothing else we can do. So this is our final answer for g over f of x. So now you know how to add, subtract, multiply, and divide functions. But there are even more operations you can do with functions. One of them being that you need to put functions inside of other functions. It's called composite functions. So if you want to learn how to do that, you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.